ago, when Africa's woodlands transformed into savanna grasslands, hominins, members of the human family, found themselves at a crossroads. Their old food sources were vanishing. They had to adapt or face extinction. One lineage, that of the so-called robust Australopithecines, coped by evolving huge molars and powerful jaws to process the tougher plant foods available in grassland environments. Another, the larger-brained Homo, invented stone tools that gave it access to a wide variety of food sources, including the animals that grazed on these new plants. With the rich stores of calories from meat, Homo could afford to fuel an even bigger brain, which could then invent new and better tools for getting still more calories. In short order, a feedback loop formed, one that propelled our brain size and powers of innovation to ever greater heights. By 1 million years ago, the robust Australopithecines disappeared, and Homo was well on its way to conquering the planet. The Lomekwi tools have smashed that scenario to pieces. Not only are they too old to belong to Homo, but they also predate the climate shift that supposedly kindled our ancestors' drive to create. And without any cut-marked bones or other signs of butchery at the site, it is not at all certain that the tools were used to process animal foods. What's more, such a vast expanse of time separates the Lomekwi tools from the next oldest implements on record that it is impossible to connect them to the rest of humanity's technological endeavoring, suggesting that the advent of stone tools was not necessarily the watershed moment that experts have always envisioned it to be. These new discoveries have scientists scrambling to figure out when and how our predecessors acquired the cognitive and physical traits needed to conceptualize and fashion stone tools and to pass their craft to the next generation. If multiple lineages made tools from rock, researchers will need to rethink much of what they thought they knew about the origins of technology and how it shaped our branch of the family tree. Dawn breaks gently in the bush, a slow brightening of sky, creeping swell of birdsong, and the team's campsite on the bank of a dry riverbed about a mile from Lomekwi 3 comes to life. By 6:30 a.m., the workers emerge from their tents and head to the makeshift dining table for breakfast, walking along a gravel path lined with stones to deter the snakes and scorpions. Within the hour, they pile into land cruisers and set off on a bone-rattling ride to the excavation. The team is down one vehicle and short on seats in the remaining two, so archaeologist Helene Roche has decided to stay at camp. Roche is an emeritus director of research at the French National Center for Scientific Research and an expert in early stone tool technologies. She has short, sand-colored hair, and she dresses in desert hues. Her voice is low and crisp. Roche led the archaeological research in western Turkana for 17 years before handing the reins to Harmond & Lewis in 2011. She has returned for the second half of this expedition to see how they're faring. I remain at camp for the day to ask her about the history of work in the region. When I started in archaeology, we were just getting used to having stone tools at 1.8 million years ago at Olduvai, Roche recalls. In 1964, Kenyan paleoanthropologist Louis Leakey announced that he had found Homo-like fossils in association with what were then the oldest known artifacts in the world, stone tools from Tanzania's Olduvai Gorge, referred to as Oldowan tools. He assigned the fossils to a new species, Homo habilis, the handyman, cementing the idea that stone toolmaking was linked to the emergence of Homo. Hints that stone tools might have originated before Homo soon arrived, however. In the 1970s, Roche, then a graduate student, discovered older Oldowan stone tools at a site in Ethiopia called Gona. When archaeologist Seleshi Sima, now at the National Center for Research on Human Evolution in Burgos, Spain, and his colleagues eventually analyzed the tools, they reported them to be 2.6 million years old. Because no hominin remains turned up with the tools, researchers could not be sure which species made them. Sima and his team proposed that